All right. A standard reference angle is taking from the x-axis and either rotating towards the y-axis, that's called positive rotation, or rotating towards the negative y-axis, that's called negative rotation. And that's why. If you rotate the x to the positive y, there's no sign change. But if you rotate the x to the negative y, there's a sign change. So that's why we call this negative rotation and positive rotation. Notice that like a clock is actually negative rotation, and we call that clockwise, CW. Right? Whereas counterclockwise, in the reverse of a clock, that's actually positive rotation. Okay, and again, the reason why is because when you rotate clockwise, you go from the positive x to the positive y, no sign change. When you rotate clockwise, you're going from the positive x to the negative y, which is going to involve a sign change. So that's why we call those negative and positive rotation. Okay, now with degrees, which is more familiar to us, if we go in positive direction, this would be 90 degrees later. This would be 180 degrees later. Add another 90 degrees, this would be 270 degrees later. Add another 90 degrees, this would be 360. Right? And so after 360, you do that again. Now, if you're doing it in the other direction, in the negative direction, then it's the same in reverse, but negative. Okay. Now with radians is based upon units of pi. And radians is essentially using a radius 1 circle to map to all the other circles that can exist. So circles are unique in that they only have one dimension. All other shapes, you're going to need more than one numerical value, right? With circles, all you need is the radius. All right. So we start here. Half of a circle would be pi, and a full circle would be 2 pi. Okay, and then in between would be half of a pi. So every quarter of this circle is worth pi over 2. So then if you want to go a quarter of a circle forward, you add another pi over 2. So this would be 3 pi over 2. Okay, and then the pi's, that can be a little adjustment to get to, but I've always thought of it as thinking of a half circle as a unit of pi. So if you wanted to split this half circle into 4 wedges, that would be pi over 4. So this would be a pi over 4 wedge. This would be another pi over 4 after pi over 2. This would be a 3 pi over 4 wedge. And then over here and over here would be continuing that pattern. So as you add pi over 4s, this is going to become 5 pi over 4. And this is going to become 7 pi over 4. Right? So notice 0, 1 pi over 4, 2 pi over 4s, 3 pi over 4s, 4 pi over 4s, 5 pi over 4s, 6 pi over 4s, 7 pi over 4s, and then 8 pi over 4s, which is the same as 2 pi. And this is true for the other ones, pi over 3s and pi over 6s. So with pi over 3s, that would be splitting up based upon splitting the half circle into 3s. Because again, this half circle is pi. So a third of that means 3 wedges. So this would be pi over 3. This would be 2 pi over 3. And then 3 pi over 3. 4 pi over 3. 5 pi over 3. And then 6 pi over 3, which is the same as 2 pi. Now, if you wanted to be basing it on sixes, then that's dividing the half circle into 6 wedges. All right, so that would be like that. All right, so this would be pi over 6, and then 2 pi over 6, and then 3 pi over 6, right? Which simplifies, and then 4 pi over 6, and then this is 5 pi over 6, and then 6 pi over 6, 7 pi over 6, 8 pi over 6, which simplifies, 9 pi over 6, which simplifies, right? And then the last one with 10 pi over 6, which simplifies, and then 11 pi over 6. And another way to think about it is, notice if you want to think about this in relation to 2 pi, this would be 1 less pi over 6, right? So instead of 12 pi over 6, it's 11 pi over 6. Same thing here. 1 more pi over 6 would be 7 pi over 6 instead of 6 pi over 6. 1 less pi over 6 would be 5 pi over 6 instead of 6 pi over 6. Another way to think about that. A question. But if you need another visualization, right? This is basically where we would draw the location of the radial arm based upon the standard reference angle. And then with negative angles, it's the same. And so notice this is going a little bit more into what we call the second quadrant, because it's more than 180. So another 20 degrees location. And so you can think of these in that way too, as far as that goes. Now, when you have a situation where the angle or radians is greater than 2 pi or 360,